Forget syntax errors. Forget missing semicolons. Imagine a world where the hottest new programming language is just English. Hi, this is AI Ascent with Dr. Jonathan Luckett. I'm your AI-generated co-host, Paula, who is going to guide you through this fascinating new paradigm called vibe coding. In early 2025, AI researcher Andrej Karpathy coined a term that started as a tweet and became a movement: vibe coding. He described a workflow where you fully give in to the vibes, embrace exponentials, and forget that the code even exists. It sounds like a developer's utopia, building software at the speed of thought, where you delegate the grunt work to AI agents and focus entirely on the creative flow. It's a shift that promises to democratize software creation, allowing anyone with an idea to build complex apps using tools like Lovable, Replit, and Google's Jules. But there is a massive catch. When you forget the code exists, you also forget who's responsible for it. We're seeing a rise in pure vibe coding, where developers hit accept all without reviewing the output, leading to what some engineers are calling development hell and rotting code bases full of hallucinations and security holes. Today, we're going deep on the vibe coding revolution. We'll explore why it was named Collins Dictionary's Word of the Year for 2025. But more importantly, we're going to dismantle the hype. We'll look at the Lovable Security Scandal paradox, where vibe-coded apps leaked personal data, and we'll explain why the future isn't about lazy coding, it's about test-driven vibe coding. It's time to find out if you're an engineer or just a prompt jockey. Are you ready to ascend? Let's dive in.
Welcome to the Deep Dive. Today, we are getting into a concept that has, it's just exploded. It's gone from a niche idea to maybe the defining practice in tech in less than a year. I'm talking about vibe coding. Coined in early 2025, Collins Dictionary actually named it Word of the Year. It just perfectly captures this new reality of how we build software.
It really has. And that cultural velocity, it's because it signals a huge shift. Yeah. I mean, at its core, vibe coding is... it's the process of generating functional code from just natural language. We're using AI tools, specifically LLMs. It moves development away from that manual, detail-obsessed process we've known forever to something more like a conversation.
A collaborative flow. So our mission today, I think, pretty clear. We have to understand the revolutionary potential for speed and accessibility. But, and this is the big but, we have to confront the very real risks. There was a major security incident we'll get into. And we need to figure out the rules, the governance, that professional teams absolutely must use to handle this thing responsibly.
And to start, we really have to define two very different things, because vibe coding gets used as a catch-all. First, you have what we could call pure vibe coding.
Okay.
This is where the user basically hands over all the technical responsibility to the AI. They often skip human review entirely. It's all about speed. The AI is treated like a magic black box, which frankly is only okay for, small throwaway weekend projects.
Right. It's the Wild West approach.
Yeah.
Instant results over everything else.
Precisely. The other side, the professional practice, is responsible AI-assisted development. Here, the AI is a collaborator, a powerful one. Think of it like a high-speed intern. The human guides the strategy, owns the prompt, but, and this is crucial, they review every single output, they test it all, and they keep full ownership of the architecture.
And understanding that difference is everything. It's the difference between a successful product and just a huge pile of technical debt.
Okay, so let's unpack this shift. Why is vibe coding really changing how we even think about programming? Especially for someone just starting out. What is the real why behind this? It all comes down to cognitive science, actually. The concept of cognitive load reduction. I mean, if you learn to code the old way, you know the pain. You spent hours, maybe days, fighting with syntax.
Oh, yeah.
Debugging a misplaced semicolon, trying to remember function signatures, or figuring out if you needed the double equals or the triple equals.
I think I lost an entire weekend once because of a misplaced comma. Just trying to get data to show up on a screen. That extraneous load, it's brutal. All those little details that have nothing to do with the actual problem you're trying to solve.
That is the perfect definition of extraneous cognitive load. And vibe coding.
Yeah.
It just vaporizes that. The AI handles the implementation details, and that frees up your mental bandwidth to focus on the germane cognitive load, which is, computational thinking.
So the human brain can finally focus on the hard stuff, The interesting stuff. Problem formulation, decomposition, abstraction, algorithm design, instead of just the language's grammar.
That is the power of it. And it creates this middle ground that just never existed before.
Oh.
You either had like super simple block-based programming like Scratch, great for the basics, but you hit a wall pretty fast.
Or you were thrown right into the deep end, full stack Python or Java with that brutal learning curve.
Exactly. Vibe coding lowers that barrier a lot.
So this isn't just about making coding easier. It sounds like it's a huge democratization of the skill.
It is. Think about it. A high school teacher, an entrepreneur, a researcher, they're all domain experts. Now they can actually prototype real data-driven applications for their specific needs without a CS degree. It expands the whole ecosystem of who can build things. And, there's a motivational factor too. This rapid hands-on approach, it feeds our psychological need for autonomy, for competency, and for relatedness. You can build something that works and share it almost immediately.
So to make this less abstract, let's look at the actual platforms that are driving this. The tools have moved so far beyond simple code completion. We're talking full-stack environments now.
Yeah, platforms like Lovable really show that shift. It's a company doing over $100 million in annual revenue now, and it offers some serious integrated features. You don't just type. You can import designs straight from Figma or even use voice input to avoid that constant context switching.
And it's not just generating a pretty button, right? We're talking about the whole stack of a modern app.
That's the breakthrough. Lovable includes what they call Lovable Cloud. It's a built-in backend, database, auth, storage. It's all there, pre-configured. It gives you instant access to advanced models like Google's Gemini 2.5 Flash without you ever touching an API key. You can even build out a whole Shopify store.
And for professional teams, I imagine it must have some guardrails built in.
It does. It has real version control, and it syncs with GitHub. Things professionals actually need.
But what happens when it goes wrong? What about debugging?
That's where a feature they call Discuss Mode comes in. It's pretty crucial. Instead of just telling it to generate code and hoping this is a dedicated chat mode for planning before it writes anything, you talk through the approach, you refine the logic. It stops the model from immediately, going down a wrong path because you've planned it out together first.
Okay, so that covers the rapid prototyping platforms. But what about the really big, complex enterprise stuff? You mentioned Jules, the agentic orchestrator.
Right. Jules is built for scale. For industrial strength complexity, it's an always-on autonomous agent using models like Gemini 3 Pro. Its real strength is managing these complex, multi-step agentic workflows.
What does that mean in practice?
So imagine you prompt it with something like, add user profile images, connect them to our auth system, and then deploy the necessary database schema changes.
Okay, for a human, that's hours of work jumping between different tools.
Exactly. You'd be in the CLI for the server, messing with APIs for the data, the terminal for config. Jules keeps the context across all of those interfaces on its own. The goal is for one high-level command to trigger dozens of correct sequential steps. It just handles the tedious work.
That completely changes the development lifecycle.
Yeah.
So what are the 5 stages of this new process?
It's pretty straightforward. It starts with ideation, which is your high-level prompt. That moves to generation, where the AI builds the UI, the backend, all the files. Then you have the loop of iterative refinement, your follow-up prompts. But then, and this is where speed has to stop, you have mandatory testing and validation. A human expert has to sign off. And only then do you get to deployment, which is often just a single click. The human role hasn't vanished, it's just shifted.
The speed sounds incredible.
Yeah.
But this is where the conversation gets.
Yeah.
Well, really interesting. Speed without governance, as we said, is a huge risk. And there's this big philosophical debate happening. Is vibe coding a real new level of abstraction, or is it just generating slop?
This is the core argument in computer science departments right now. The proponents say, look, just like the C language abstracts away assembly, vibe coding abstracts away syntax. You just focus on the what, not the how. But the skeptics, and there are many, they argue that LLMs are fundamentally non-deterministic. You mentioned the random code tumbler idea.
Right, meaning you can give it the exact same prompt twice and get 2 completely different, maybe even broken results.
That's the heart of the problem. True abstraction, the critics say, should free you from the lower-level details. But with an LLM, you have to constantly steer it, correct it. If you have to inspect every single line of code it writes, which you absolutely do, then it isn't an abstraction. It's more like a very fast but completely unreliable intern. Or maybe a monkey's paw.
And that risk isn't just theoretical. The sources point to a really crucial case study here, the Lovable app incident in 2025.
That incident was a massive wake-up call for the whole industry. Lovable had security scans built into its platform, but an audit found something devastating. 170 of the apps built on the platform out of about 1,600 had critical security vulnerabilities. They were leaking personal user information.
And that's the core of the lovable security scan paradox, isn't it? The automated checks just aren't enough because the flaws are conceptual, not just syntax errors.
Precisely. The problems weren't simple things like SQL injection that a static analysis tool can catch easily. The vulnerabilities were architectural. For example, the AI might correctly generate two different microservices, but it would fail to implement proper token validation between them, so one service could just impersonate the other. That kind of deep flaw requires a human architect to spot it.
And what about 6 months later? When a new developer has to come in and fix a bug in this AI-generated code, the maintainability must be a nightmare.
You are immediately in development hell. Pure vibe coding creates crushing technical debt. LLMs don't care about your project's style guide or common design patterns. They just generate what works in the moment. The result is a code base that is totally inconsistent, which makes it incredibly hard for a human to debug or build on top of.
So if the risks are that high, what's the playbook for professional teams? How do you get that incredible speed and cognitive benefit while, avoiding the disaster we just described? What are the new rules?
It starts with redefining the human-AI rules. We're splitting the job in this new kind of pair programming. The human developer has to become the conceptual architect. They're the navigator. They set the strategy, they make the big decisions, and they review everything that gets generated.
And the AI is the driver. It just focuses on implementation. It can suggest a refactor, but it's only ever following the human's lead.
Absolutely. And the single most important governance layer we can add is something called test-driven vibe coding, or TDVC. It's just applying the classic principles of test-driven development to this new generative workflow.
But hold on, if the whole point is speed, isn't writing a bunch of tests first just trading one time sync for another, swapping syntax writing for test writing?
That's a great question, and it's a critical distinction. The time sync is different. Writing syntax is mechanical. Writing good tests is conceptual architecture. TDVC forces the human to write those definitive policing tests up front. Those tests become the objective specification for the AI. It's the only way you can prove its output is correct and instantly catch problems when it generates a new version. It shifts the senior developer's value from typing to defining integrity. It's much higher leverage work.
That's a powerful way to think about it. Okay, let's finish with some actionable best practices. 4 things you can do today to get this right.
Number 1, keep scope tiny. This is where people fail most often.
Bro.
Don't ask the AI to fix my entire code base. That's way too much context. Feed it the smallest possible piece of the problem, a single function, correcting one data flow. It prevents the model from just making stuff up.
Micro tasks, not macro projects. Got it. What's number 2?
Be explicit. The AI is not a mind reader. You have to spoon feed it constraints, tell it the exact folder structure, detail the data flow, define the state management, list the edge cases you care about. If you don't define the architecture, the AI will indent one, and it probably won't fit your system.
Which is how you get that inconsistent code rot.
And that leads right to number 3, regenerate, don't patch. Avoid those really long chat threads where you keep asking for little fixes. That's how inconsistency creeps in and rots your code base. When the code gets weird or too complex, just reset the chat. Simplify your original prompt and rebuild over patching. Just start fresh.
And finally, what's the ultimate rule? The layer of human accountability that really defines being a professional in this new world.
It's the accountability mandate. No line of code gets committed unless the human developer can explain its function, its design, and its impact on the rest of the system. It ensures you maintain professional responsibility. You have to own the code you ship, even if you didn't physically type it.
So this deep dive really confirms it. Vibe coding isn't a trend. It's a permanent acceleration of how software gets made.
Yeah.
But it forces us to elevate the developer's role, from a typist to a strategic architect and a validator.
Exactly. The value of a senior developer is now all about their ability to orchestrate these agents, to manage the risk of this non-deterministic code, and to focus on that high-level design. The work has moved from the keyboard to the whiteboard.
And that kind of high-level thinking, it requires deep focus. We spent a lot of time today talking about how AI reduces the mental friction of coding, right? Letting you focus on conceptual thought. So the ultimate productivity hack now might be removing the physical friction in your own environment. So think about this. as the AI handles more of the implementation. What one physical thing in your workspace is your thermal comfort, keeping it between 20 and 24 Celsius? Is it getting rid of monitor glare? Is it managing sound? What are you going to fix this week to create more space for that deep, high-leverage thinking that this new era demands? Great workspaces aren't bought, they're iterated.
So where does that leave us? It seems clear that vibe coding isn't just a meme. It's an irreversible acceleration of how we build software. But as we've learned today, the vibe can be dangerous if it's not grounded in discipline. The biggest takeaway here is the vibe paradox. AI lowers the barrier to entry so beginners can build apps instantly, but it actually raises the bar for mastery. To do this professionally, you can't just be a coder anymore. You have to become an architect and an orchestrator of autonomous agents. We're moving from the traditional software development lifecycle to the agentic development lifecycle, ADLC. In this new world, you don't write the code line by line, but you must write the tests that prove the code works. As we discussed, test-driven vibe coding, TDVC, is the only safety net we have against the chaos of accept all. Andrej Karpathy may have told us to forget the code exists for weekend projects, but for the enterprise, the human element, your ability to review, secure, and understand the architecture is more valuable than ever. So by all means, embrace the vibes, let the AI handle the syntax, but never ever forget that you are the one responsible for the system. Thanks for listening to this episode of AI Ascent with Dr. Jonathan Luckett. We'll catch you in the next flow state.